Hi, in this second tutorial, I am again going to show you another mode of VollSeg, and in this case, it is how to do segmentation of tissue, which is a time-lapse sequence. So let's say you image a tissue and you have a directory which contains a lot of 2D images of the tissue, and it's actually a time-lapse sequence, so you want to do the segmentation of the whole time-lapse sequence. And in one of the modes of VollSeg, what you can do is you can actually import your so first thing you have to do is import all of your 2D images and make it into an actual time lapse. So the axis of the saved image is going to be dy and x, and you can do this by opening PG and then import sequence of all of the files in the directory and then saving that as a time lapse. And then you can use VollSeg to actually use the Unet model that you have trained to do the segmentation of the whole time lapse sequence and then save the mask directly from the plugin. So right now the plugin is in developmental mode. So if you want to use it now, what you have to do is you go to my GitHub page, Kapoor Labs Paris, and then you find the repository VollSeg. You click on the code and you copy this, and then you use your git bash terminal to actually clone the repo and put the code in your computer. So just paste this link over here, and it's going to bring the source code over here, and then you open your Anaconda prompt from where you can actually launch Napari. So you have to open the Anaconda prompt, start your virtual environment, and then just type Napari, and Napari should open. And once you have done that, and that you have the code in your computer now, which I put it in the downloads folder. So what you will see then is you can have the plugins over here, and then you can just drag and drop the VollSeg Napari folder that you just cloned into this tiny little box here, and then you can click install. So I have already installed this one before, but this way you can also just install it and then it will appear like what you see over here. So you close this window and then you go plugins VollSeg, and then this should open. And the plugin remembers all the choices that you made. So in the case that you want to do the segmentation of just the tissue, there is no status model, there is no denoising model. It's only a Unet model, which is a customized Unet model that you train on your own dataset. So you just have to choose the directory of where the model is. Then you have to open the time-lapse image that you saved by stitching all those 2D images in time, which would look something like this, right? Now you have to take care that your axis is t, y, and x, and the model axis will be y and x because it's a 2D model that you trained. And another important thing to know here is the number of tiles, because typically your laptop GPU is quite limited, and the images that you have are pretty big. So what you would have to do is make a tuple here, like 1, 4, 4, which means in time axis there is no tiling. The program will internally ignore the 1 that I put there, but it's going to break your image in x and y into 16 tiles. And then it's going to apply the prediction of the Unet model that you selected time point by time point. So once you see the run button over here, you just click run. It's going to start the process on the GPU. It's going to show you the progress bar, which is over frames. So it will show you how the program is progressing frame by frame. What it's doing, it's applying the prediction of the model for one time point, then going to the next time point, and it's not going to show an output when it's actually doing anything other than just having the progress bar show that it's actually working. By the end, when it reaches 100%, you will see that on this left hand side, a new layer will appear. That layer will correspond to the segmentation of your tissue, which will be a binary image. And then using the Napari files panel, you can just save that particular selected layer, and that will save you the TIFF file of the segmentation that you can then use for further processing. So till then, you just wait for it to hit 100%. And once it hits 100%, then you will just see something appearing on the left hand side. So by default, the visibility toggle is actually set to blind, but you can do this with the eye button, and then you will see the segmentation overlaid on your tissue for the time-lapse sequence. And now to save this, you just click here, go to File, Save Selected Layer, and then choose a folder where you want to save this segmentation image, and just give it a name, segmentation mask. .diff, and that will save the segmentation image for you. And in this way, you can very quickly on your GPU computer of your laptop actually get the segmentation of the time-lapse sequence without having to go through the complications of Jupyter notebooks where you would have to know if it's a notebook which is meant for a time-lapse or if it actually is taking a directory of Y and X images. Now it's simplified. Now you just make a time-lapse, use this model that you trained for getting the segmentation. And if you have any questions or comments, leave it in the comments box below or just email me and I'll be happy to answer it for you.